Good afternoon and welcome to our webinar, Trends and Best Practices in Layer 1 Infrastructure. My name is Kevin Cook and I'm a Market Development Manager with Terakai Corporation. Today I'm pleased to introduce Josh Taylor. Josh is a Senior Product Manager with Cable Express, a layer infrastructure manufacturer and leading provider of fiber optic solutions. Today we're here to talk about Layer 1 infrastructure and how it has evolved over the last 15 to 20 years. And with the confluence of key industry trends, the ratification of new standards, and a new architectural best practices approach, you really should be paying close attention to your Layer 1 infrastructure. And so without any further delay, please welcome Josh Taylor.
Thank you very much, Kevin. It is an honor to present to you today. I really do appreciate you showing up. Please feel free to ask questions. I encourage you. That way I know my material was appropriate. And we'll get going from here. I think the first thing I'd like to talk about is where have we come from? And if we look at these columns here, we see some years, we see the application. You'll see we're following Ethernet. We see the data rates next to that, and the standard, maybe not appropriate this time, but most importantly, the dB loss budget. Later in the presentation, I will get into more specifics about dB loss budget, but you can see these numbers as you follow down the column start to shrink. But more importantly at this time, look at how we start at the top left in 1982 with Ethernet at 10 megabits per second, and now in 2010, we're looking at 4,100 gigabit. You can see that we start to make some pretty big jumps. We kind of start to grow exponentially. And now when we go to the next slide, we'll see for you accounting majors, we have a hockey stick graph that I think shows this, basically this transition. So you can see we have jumped up radically or exponentially in speeds. This is a very, very important thing to note. We have gone along for quite some time, relatively flat, and now look at this major jump. It's good to point out today, let me go back one slide, just some of the basic reasons. Probably a lot of us know this, but it's always good to reiterate. Bandwidth demands are increasing. Right now, all of us are viewing video. This eats up bandwidth. Uptime demands. I haven't heard anybody who says they can deal with downtime in any aspect of their network. Flexibility and growth. It's safe to say back in the early 80s, late 80s, maybe early 90s, when a lot of data centers were put into place, probably the data center that you have right now, people hadn't imagined how fast and how far we would come at this time. This also goes along with the connector evolution. This kind of tells that same story. Back in the early 80s, it was very prevalent. The SCON connector, some of you may be familiar with right there in mainframe type of applications, and the FT type of connector. That's kind of that first generation there. And then you saw when we started to get into the 10100 range, maybe a little bit into the gigabit range, we had the SC duplex and the MTRJ connector. And then what most of us are familiar with now at this time is the LC duplex type of configuration. And where we're going to be going and where some people are currently, actually quite a bit of people are moving there now, is generation 4, the MTP or MPO style connector. So let's take a minute just to talk of the importance of Layer 1. I live and breathe cables. It's all I do. And I know I'm also realized, I do understand there are a lot of different levels at the application layer, different layers. There's a lot of things to think about. Working in information technology is a very, very, very complex type of job. There are a lot of things you have to think about, and there are a lot of unknowns and different factors that have to be shared. Well, think of a pyramid and Layer 1 being the base. If you don't have a solid Layer 1 or a solid base to your pyramid, things can get very rocky. Or, things could get in, you could get in trouble quickly. And I want you to think back to the graph we showed how things have grown so quickly and how things have paced so quickly and what that could mean. And look at this stat here, 50% of system outages are related to cabling and rapidly increasing. We see that firsthand on a daily, weekly basis. And it's happening with these increased speeds. I had mentioned a lot of data centers were implemented early 80s, maybe late 80s, early 90s. The technology was very, very different. Cost of downtime. You know, I think probably everybody knows. 1 out of every 4 data centers will experience a business disruption. It's true. We've seen that. And, the costs can vary significantly, but I don't think I've ever heard anybody who said, no big deal. It's always a big deal in one way or another. Now I'd like to point out some key industry trends. This is really where we start to, understand what is happening now, why this is so important to pay attention to Layer 1 at this time. If we start at the left, this is kind of our status quo server type of situation right here. Probably most of you are familiar with this type of setup. Then we move to that middle diagram, and this is where we have some server virtualization with the storage and the data. But if you notice, you have less lines, basically, less connection points. And then over to the right, here you have a converged storage and data scenario. And again, you can see you have these much bigger pipes. And throughout the presentation, I like to use a plumbing analogy. So when I say pipes, I hope you know what I mean by cabling runs, cable infrastructure. And again, maybe to highlight this point, more bandwidth needed over fewer cables. That's basically what you're seeing. And again, using the pipe or this simple diagram, before virtualization and convergence, you were running a lot of cables, different redundancies, and less information went over them. Now, with the higher speeds on top of the virtualization and the convergence, you have a lot of data going into one pipe or into one cable or system of cables. So let's tie that into best practices and standards. It's very important to look at this. I'd like to say this is an area where my group works quite extensively. There is a lot to this. This could be 3 webinars versus of material right here. So I'm going to glaze over some of this, and I want to give you what I feel are the very important factors. And we can, if there's questions, we can potentially take them offline or answer them at the end. But there's a lot more to this. I'd like to start with the TIA series, and a lot of you are probably familiar with the TIA. They have a big standards body. Well, the 942 is a design standard. It's very important. We also have the 568C, which is a premises application standard, and then the 606A, which is a labeling standard. And we also have BICSI, which is another organization, and they have a data center design and implementation standard. The TIA 942 and also that BICSI data center design and implementation are very, very important. The design of a data center is of utmost importance. It needs to be modular. You have to have upgrades without disrupting cabling infrastructure or as little as possible. And you also have to be scalable. You need growth without disrupting that cabling infrastructure. This is very important. Again, going back to the point of in the early 80s, late 80s, it wasn't foreseen how much moving and changing was going to happen, how much hardware retrofits we had. So setting up a design like this is very important. Again, there's a lot to this, but in basic form, all of your equipment should run up to a patch panel at the top of your rack, and then you should trunk, whether it be copper or fiber, into zone distribution areas or main distribution areas. This can vary greatly on the size of your data center. But really what you want to end up with is, my analogy would be the old phone operator where you have a switchboard at this main distribution area. So all your adds, moves, and changes, they happen in that area. That may be 1 rack, maybe 2 racks, 5 cabinets. Again, it can vary. But that's the most key thing right there. You can put your equipment in, your switches, your Nexus switches, shut the door, and then do all of your changes outside of that. Look at this versus point-to-point. And when I say point-to-point, that simply is you put in a new piece of hardware and it's got to connect to a server, whatever it's going to connect to. You take a patch cord, you run it from point A to point B. This is pretty much where things started. We've seen the problems that has happened. You probably have yourself seen these problems. When you run point-to-point, just like in these pictures, this is what happens. A, it's not pretty to look at. B, it can cause downtime in a myriad of ways. You see those cables running over the other cables. Not good for your performance. With the loss budgets that we'll get more into, that is also not going to be helpful to you. You're going to incur quite significant amounts of loss right there. And then we have standards on generic telecommunications cabling for customer premises. And these are very large overviews. Basically, you can see the bullet points of what this covers: pole tension, bend radius, et cetera, et cetera. These are very big standards, but very important. A lot of different ways to plan and map out your infrastructure. And then something a lot of people don't want to deal with, don't want to do, but something that's very important is the 606A1 standard administration. Basically, it's labeling. It's something that we help out people with quite a bit. It's just important to know about this. And again, it helps you with your overall design of your infrastructure and efficiency of your infrastructure. And then we get to, I think, as part of the meat of this presentation, the 802.3BA Ethernet standard. We've been looking at this to come to fruition for a few years, and over the summer it did. And this is going to be very impactful for the next 5 to 7 years in the roadmap of pretty much everybody's infrastructure right here. It covers a lot, but there are some very, very radical changes to the way cabling infrastructures will look and how this standard affects them. So I'd like to spend a little time here and just to show you, let's take a quick review of what 1 and 10 gigabit look like right now. As you can see, that transceiver on the right, pretty much most of you should be familiar with that SFP style transceiver, and then the LC duplex cable. It's how we're doing things right now, the status quo. So what would 4100 look like? Well, there you see 2 different MTP connectors. And in the bottom middle, you see a transceiver that looks a lot different than the one you saw on the slide before. That's a picture of a 100 gigabit transceiver that would accept that MTP connector. So now to further delve into this, just to give you the kind of the practical way this will work is, right now the LC duplex works as a transmission of this. You see one is a send, one is a receive, each fiber. So it's pretty simple. That's kind of how we do things now. Now, this highway analogy I think is great here. If you look at, you have 4 lanes now transmitting 10 gig, and then 4 lanes receiving 10 gig. So I think you probably see where I'm going now with the MPO connector. One important thing, just a quick stop here, is there are a lot of different variables now. Instead of just simply trunking 10 gig lines together, there are other factors, technical factors. One of them is skew, and I won't go way into this, but basically signals have to arrive within nanoseconds of each other. It's very, very critical. Cabling infrastructure needs to be able to meet this demand. So again, back to the parallel optics. Here's a great example. You see on the right, you see what an MPO or MTP connector looks like. And then you see a graphic diagram of that. The red represents your transmit, and then the green represents your receive. This is basically how 40 gigabit Ethernet transmission is going to work over a multi-mode application in a data center. Now, when we migrate to 100 gigabit Ethernet, the transceiver is going to look like what you see on the left. Now we have 10 transmit and 10 receive. So what is dB loss? This is going to be something that's very important. Well, the definition, it's light measured in dB, which is decibels, that is lost between the transmitter and the receiver. How does this happen? Well, it can happen over distance. It just kind of naturally happens with the friction over the glass itself. It can happen at splice areas, and it can happen at mated pairs. A loss budget is the amount of light that you can afford to lose without running into data errors right there. You know, on the right, again, I kind of have an analogy picture of here's you losing light in the form of water right there. Okay, so loss budgets are important. When we had looked at this before, we were looking at the, you know, how fast the speeds have increased. Well, now pay attention to the column on loss budget. We started at 12.5, 11, and then down to 4. You see there's a big jump right there. And then where we end up at 4100 gig, look at 1.9. This is a very, very important piece because, as I had said, a lot of data centers and cabling infrastructures have been put in years and years ago, potentially field terminated. It's very, very important to look at this loss budget number. You may go to upgrade to maybe even 10 gigabit, but at 40, 100 gigabit, and run into major issues because your cabling infrastructure cannot handle this. You are losing too much light at your interconnect points over the distance or any of those other reasons. So that's really the point to look at the drive home. This is a pretty radical jump right here. Also combine that with what I just talked about with design. Have to keep that in mind. You can't just run from one point to the next. It just doesn't work. We've seen it over and over again. No matter how you try and do it, when you run point to point, it's going to cause you major issues. It's just no way to organize it with all the adds, moves, and changes and scalability that you need. So where does loss occur? Well, let's talk about the mating. It's when two fiber connections are put together. This happens in patch panels, in trunking, and interconnects. And then let's talk about core alignment. And if you see the picture on the top right there, it's kind of a graphical view, but you see those two cores, when they press up against each other, they're not exactly going to match. And that's probably the best visual you can have. Every time you are mating two fibers together, again in like a patch panel or something, you have the potential for that to happen. Precision components are critical for something like this. You want to make sure that everything is mated up exactly. The core alignment is very, very important. Also, if you see at the bottom, there's different core sizes. It's of utmost importance never to mix and match different core sizes. We have 9/125, 9 being the core size, 125 being the outer buffering of that. Those are measurements in micrometers. So we have 3 different core sizes. Again, if those cores don't match up, it's not going to work very well. To use the plumbing analogy then, or I guess a water analogy, it's like putting a garden hose into a fire hose and turning on the water, and vice versa. You're going to have water spilling out all over the place, or we could translate that to data. Also the assemblies, the components of a fiber optic jumper, they need to be precision mating components as well. If you have those are off, as well as your alignment between two different connectors, you then have double the miss, if you will. And that is highlighted again on that top picture to the right, where you see the two circles next to each other. So what occurs at the mating points? Again, this is, you know, at a patch panel, and I show that on the bottom left. I kind of have a little graphic of what I call a module, something that you would plug an MTP into, and then you would plug your LC duplex jumper. And then right next to that, I have a picture. This is a test piece of equipment that we use in our production facility. That it's just a powerful microscope, and you see the series of circles with the big circle in the middle. That's where the center should be. but the actual center is off to the right as you are facing it. That is an example of a misaligned core, and that could happen very easily in some sort of fiber optic cable. You don't want that to happen. That's a very important thing to at least understand that these things can happen. There are a lot of different tools that measure this, very expensive type of tools and scopes that measure this. Some of those outputs are shown on the right there. So what happens at these mating points? Three things. Pretty simple from there. A certain amount of light passes through. This is what you want to happen. The data goes from point A to point B. It just passes right through that mating point. Another thing that can happen is back reflection. During this, at this mating point, the light bounces back, and that quote-unquote confuses the signal, which is not good. And the other thing that can happen is with improperly aligned cores, the light just shoots off and goes off somewhere else, not where you want it to go. Okay, so again, I'd like to come back to this. With that said, now we look at these loss budgets. Just hypothetically, you had your data center fiber cabling infrastructure was implemented 5, 7, 10 years ago and had used field termination, or you would use products that used the standard, the industry standard type of loss results. If you were trying to get that fiber infrastructure from point A equipment to point B equipment with 5 interconnects in between at an average loss of 0.5, you're going to be at 2 dB or over that loss budget. Again, when you're over the loss budget, that's where you're more than at risk. You're going to be exposed to data droppage. Things are not going to work right. They may not just work right off the bat, or they may just have infrequent failures. Probably most customers I talk to can sympathize. They're usually looking at the hardware first, trying to track this problem down, and then the cabling second. So just be forewarned with this. That's an important message right there. But again, it's important to point out these loss budgets are going to become very, very, very tight. It's very critical to look at any investment you make in your cabling infrastructure now with these points I'm talking about.
Excellent, Josh. Thank you so much for the presentation. We've actually got a few questions coming in. First question comes from Steve, and Steve wants to know about that MTP connector, and can that connector be field terminated?
That's a good question. So I'm gathering that you're familiar with the MTP connector, and at this point I wouldn't recommend field terminating an MTP. I don't believe there are any products on the market that I've seen to field terminate an MTP. It's just the precision it takes to terminate an MTP is just too great at this point. You really need a machine, a polishing process that is exactly, because now you don't have 2 end faces, you have, or 2 fiber protrusions. Now you have 12 fiber protrusions. So it just isn't possible. However, on the market there are field spliceable MTPs with pigtails on them. So that is something that's viable. In some cases, it is not practical to have a factory terminated type of assembly, and I would always recommend factory terminated at this stage of the game with an MTP. But if that is impossible, there are some field spliceable. So hopefully, and if that doesn't answer your question, or if you'd like more information on that, Steve, please contact us back through the webinar or email contact, and we can get into more information on that.
Josh, here's another question that came in. This one more to your loss budget example. The question comes from Tim. Tim wants to know, how do you go about calculating loss budget?
Okay. Well, as we saw, I had the chart up a few times. You know, there is a loss budget specifically to each speed that you're going to run. So I would familiarize yourself with that, and we could send you these slides or that chart essentially for you to use. But then also I think you would want to know, you would want to map out your infrastructure, and you would want to know how much loss you are incurring so you can match those two. So A, find out your loss budget, what speeds are you running, and then B, I would find out where where you are, where your current infrastructure is.
So here's a question from Scott, and Scott wants to know regarding field termination, is a factory terminated pigtail splice an option to get to an MTP or an MPO connection?
Yes, and absolutely. And I can't remember who does it, but there is an option for that with a pigtail splice. Again, I'd always recommend, just because again, splicing you will incur loss, but I would always recommend a factory termination wherever possible with the whole assembly. But absolutely, you can get a field spliceable with the factory polished MTP on it.
Okay, here's a question from Paul, and Paul wants to know how many transmits and how many receives are needed for 40 gig over single mode and 40 gig and 100 gig over single mode fiber.
That would follow the same principle as the multi-mode. However, there are a few other details with the standard. Technically, with single mode, you could also use a serial or duplex type of transmission to obtain 40 and 100 gigabit, and it has to do with CWDM, WDM type of technology. And that it greatly depends on the transceivers you're using. But I think to simplify, I just want to put that in there as kind of a caveat, but to simplify, speaking of parallel optics, every line, every fiber will be transmitting 10 gig. And again, this varies by the transceiver. So with 40, you'd be transmitting at 4 fibers, and you'd be receiving on 4 fibers. And then at 100 gig, you'd be transmitting on 10 fibers and receiving on 10 fibers.
Here's a question from Judy. Judy wants to know, how can we evaluate, or where do we begin to take a look at our cable plant infrastructure today and what it's capable of delivering?
Okay, that's an excellent question. Also, there's quite a bit to it. So just kind of starting at the top, it's probably best to map out what you have. Things can get complicated pretty quick if you are running, say, point-to-point type of structure, but it would map it out. Pay close attention to what type of cable, core size, and connectors, and then those mating points at the patch panel, and how many different interconnect points you have in between. That'll be a very important thing to evaluate. With that, talk to someone like us. We'd be glad to kind of make an assessment of that point, because you want to measure that basically against your roadmap of where you're looking to go. And I think, again, most of us, and I guess if you had signed up for this webinar, you're interested in, so you want to know what things are going to be like at 40, 100 gigs. So you can map it up against that and see how you stack up. From there, you would like to find out how much loss you have incurred. Now, you could have, if you have an OTDR, that's something that you could use, and you could find out actually how much loss you do have in those channels, from point A to point B, and you could weigh that out. But it's going to be very important for you to know how many interconnect points you have and what your loss is per channel, and really all the types of media you have. Again, being single mode fiber, multi-mode fiber, what type of multi-mode fiber? Is it orange 62.5 or orange 50 over 125? Or is it the newer type of aqua color jacket, which could be OM3 or it could be OM4? Again, for more information on that, you can certainly contact us. There's a lot of details to that as well. And again, Judy, if that doesn't answer your question fully, please contact us, and we'd be glad to go into more detail on something like that.
We have a question here also about copies of the TIA standard, and as Josh had mentioned, copies of the presentation. This presentation will be online in the next few days. In terms of copies of these presentations, please don't hesitate to reach out to us. We could certainly get you copies of many of these standards and specifications and best practices as it makes sense. JT, anything else to add?
Well, on the TIA, you had mentioned the TIA standards. Those are those we cannot give out. Those are something you need to buy, and they're governed strictly by the TIA and/or BICSI. But I would urge you, we can certainly talk about them and translate what they mean. We live in those documents all the time and would be more than willing to talk about them. They're very important. But I'd also encourage you can go on the web and go to, I think it's TIA.org, and you can purchase those standards. They're not typically cheap. But again, if you're interested in it, you're looking to future-proof your infrastructure, whether you're building or you need to brand new build or you're retrofitting something, I think is of utmost importance at this time to really question and look at everything you're implementing. You can see now more than ever, you want this infrastructure to last as long as possible. You want to get a better return on your investment. I hear a lot of aggravated people when they have to tear out their infrastructure, put in a new one, and it was just 5 or 7 years ago, and then they have to do it again. So again, I'd urge you to look at those standards and see where set things up according to them. And of course, we are definitely willing to help with that.
Excellent. Thank you, JT.
You're welcome.
And thank you all for your participation and your insightful questions. I hope this webinar met your expectations. Terakai Corporation will be hosting these regularly, and we'd love your input on topic ideas. Thank you again, and good afternoon.